Hi, I'm Michael Patterson, and we are talking about better brains by design. This is the idea that we actually can figure out how to design our brains by taking advantage of the plasticity of the brain, so we can design our brains to be stronger, to be sharper, and to flourish as we go forward through our lives. So we're focusing in these sections on this whole idea of plasticity and sort of getting in. One of the questions that comes up when we say you can design your future brain is like, wait a minute, how do you do that? What's the science behind this? Part of the science is, really a fundamental part of it is this neuroplasticity of the brain. And plasticity changes, your brain changes, your whole body changes in response to what we do, what we think, what we feel, and so on. And it changes on all kinds of different levels. It changes on the even down to the molecular and the cellular level. It changes in terms of your systems. Your circulatory system will change and behave differently. Your breathing will change. Your immune system will change. And what's remarkable is that even your behaviors change, and they affect all of these different areas. You can go bottom up, changing the molecular and cellular stuff will change your behavior. Just as importantly, your behavior sort of percolates down through systems and can actually change the molecular and cellular structure of your brain cells and your body cells. So since behavior is what we can do and what we control, our approach in terms of designing better brains for yourselves is to really focus on the behavioral aspects, because through even what we think, by thinking in different ways, by holding different belief systems, that manifests itself through physical changes in your body, in your brain. Norman Doidge is a Canadian physician who has written 2 wonderful books where he reviews all of the science on plasticity. If you're interested in the subject, I recommend The Brain's Way of Healing is his most recent one, and The Brain That Changes Itself is the previous one. In reviewing all of these stories of remarkable examples of how people have used their minds essentially to change the plasticity of their brains and to heal themselves, Doidge feels that he has come up with an understanding of the basic things that we need to do. Well, let me back up first, and he says, a couple of the things that go wrong with the brain that can be corrected by neuroplasticity are important to talk about. One of them, he says, is learned non-use. And this is where it's most dramatic if you have an injury, for example, or a stroke, and it knocks out, say, use of your right arm. Current therapy used to be to try and get that arm, to compensate, use the other arm. What they do now is they take the good arm and strap that down and force the good arm to work. Because what they realized is the cells are not necessarily dead. Some of the cells have died in your brain, but a lot of the cells around it are still alive. And if you continue to send signals back up to the brain, the neuroplasticity, cells that were not specifically used for that purpose initially can pick up that purpose, and you can recover a lot of your stuff. But it's this learned non-use. If you don't use your body or specific types of activities in certain ways, your brain will eventually learn, we're not using those brain cells, let's put the resources somewhere else. The important point about that is that those brain cells are not necessarily dead, they're just dormant. So a lot of what the neuroplastic healing is going in and reviving them, waking those brain cells up again by using them in specific ways. So a lot of what we do when we're developing strategies to design better brains is to figure out what is not working well, what is dormant, and how can we stimulate them once again. Deutsch talks about three main areas, or we've sort of reduced it down to three main areas that are important. One is if the actual cells of the brain are not functioning properly, you've got to make sure that they're functioning properly. So there are various things that you can do to stimulate the repair of brain cells. Remarkably, something like exercise, simple exercise, physical exercise, produces this neurochemical in your brain called brain-derived neurotrophic factor, or BDNF. What BDNF does is go in and repair brain cells. I mean, one of the things that it does. So the more you exercise, the more you produce BDNF, the greater chance you have of actually repairing brain cells that are damaged. So that's the first part, sort of repair and protection. The second big area of plastic change that we can affect can be summarized sort of as modulation or normalization or standardization. The systems in our body tend to swing back and forth, like our breathing generally keeps at a steady rate, but when we need to exert ourselves, it can ramp up and we breathe harder, we get more oxygen flowing, more blood flowing. When we relax, we come back down. The autonomic nervous system that either stimulates us to deal with a crisis, kind of fight or flight. When that challenge is over, it calms us back down. So you have this constant fluctuation of systems. What tends to happen when things go wrong is that the balance gets out of whack. Either you're too far on one side so that you're stimulated all the time, or you're out of whack on the other side, that you can't get stimulated when you need to be stimulated, or the range has gotten way out of whack. So there are various things that you can do to kind of normalize that, get your systems back to where they're functioning properly. Meditation, interestingly enough, is one of those areas where what you're doing is training your body and your brain to get your autonomic nervous system back within the proper modes. So first is get your brain cells, repaired and protected. Two, normalize the systems. Then, once you've got that system to where it's all working the way it can, then you can actually use your brain to grow and to learn and to, so you're not fighting so much against just to stay healthy. You've got a healthy, strong brain. Then you can really use the plasticity to build new connections, to increase the networked connections, the assembly of neurons that are really what make up our complex thinking. So I'll leave it at that. Neuroplasticity is incredibly exciting capability of the human mind, and we're now beginning to learn how to leverage that plasticity so that we can actually design better brains that will help us live longer, better lives.